Hi, welcome to Learning Monkey. I am Raghuir. In this class, we do some gate bits. The basics to understand these bits is already provided in our previous classes. Please watch those classes and come back here. The link for the playlist is provided in the description below. Coming to today's examples, this is the example given in GATE 2001. Let's read the question. Consider a DFA over alphabet A comma B, accepting all strings which have number of A's divisible by 6. The sequence of strings should contain the number of A's should be divisible by 6. It should not be continuous A's. A's can be in anywhere. And number of B's divisible by 8. The similar example we have already discussed this in our DFA practice examples. Let's show me that example so that you will get the clarity. So take this DFA practice examples. This is the example which we already discussed. See here, design DFA that accepts strings with number of zeros or multiples of 5 and number of ones or multiples of 3. In order to construct this, we use this horizontal and vertical method. Horizontal, it is going to accept multiples of 5 zeros. Vertical, it is going to accept the multiples of ones. Multiples of ones. In order to identify 5 zeros, 5 states are needed. In order to identify 3 zeros, 3 states are needed. 3 states are needed. So total, how many states are required? 5, 5, 5. 5 3s 15 states. So 5 is needed to identify the zeros, 3 are needed to identify the ones. So total 5 3s 15 states. This is the minimized DFA for accepting the strings that contains zeros or multiples of 5s and ones or multiples of 3. The same way, or coming to our example, this is our example. So if you don't have any idea how we have constructed that, please watch those class DFA practice examples class so that you will get idea about that how to construct the DFA. Here it is asking that divisible by 6 and divisible by 8. 8 6 48. So how many states are needed? 48 states are needed. So the answer is 48. This is how we will construct that. That's why the basics which we discussed, the examples will help you a lot in solving the gate bits. Coming to the next example, GATE 2002, it is given in 2002. The finite state machine described by the following state diagram with A as starting state. This is the starting state where an arc label is given as x/y and x stands for 1-bit input and y stands for 2-bit output. This is a Moore machine. The output is present in the transition. On the transition, that's why it is a Moore machine. But here it is going to display 2 bits as our output. Let's try to understand what this is going to display. This output is going to display. Whenever you find 0, it is showing that the output is displayed as, if the input is 0, output is given as 0 0. Let's take one more example. If you take the input 1, we are moving to here. What's the output? It is going to display 0 1. If you take input as 1 1, the output is displaying as 1 0. What we understand from these two examples? Whenever you see 1 1, they are showing the binary value of 1. 0 1 means in the binary it is 1. Whenever 1 1 means 2, binary of 2 is 1 0. 1 1 1, what it is going to display? 1 1 1. Last two inputs are 1 1. That's why what's the addition of 2 ones? 2. That's why it is going to display 1 0 in binary format. 1 0 means 2 in binary format. 1 1 0. What's the last two input bits? 0 and 1. If you add these two, 1 plus 0 is 1. That's why it is showing 0 1. That's why it is showing 0 1. Means what it is going to display? This diagram is going to display the last in your string. It is going to display the summation of the last two input characters, summation of the last two input binary numbers. That is represented as an output in binary format. So the output is, the answer is outputs the sum of the present and the previous bit. Last two means the present and the previous bit of the inputs, bits of the inputs. The sum of the present and. Second one is output 0 1 whenever, no, it is not. Output 0 0 whenever the input sequence contains 1 0. No, the answer is 1. So this is how we will identify based on the basics which we covered in our previous classes. We can solve the gate bits. Hope you understand the concept. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.